Hello and welcome. So today we are here to see this question to find the second smallest in the array. So this is pretty simple question and straightforward. So we need to find, given an array, we need to find out the second smallest element. Second smallest element. So from this example, what is the second smallest element, guys? So we have 8, 4, 10, 17, 19, 20. So the second smallest element is 8, right? Second smallest element is 8. Now, what will be the simple and straightforward approach that we can think of this question? So if you think, we can simply, if you think of the brute force approach, what we can do, we can simply sort this particular array. And what after that, we can simply sort the array and element at index 1 is second smallest, right? That's all. Simply sort the array and element at index 1 is the second smallest. Now, if you take this above thing, if you take the same above thing, what will be the array after sorting? It will be 4, 8, 10, 17, 19, 20, right? So now what is the second element? 8, which is our second smallest element. That's all. Pretty simple. Now, the point is, the point is, what will be the time complexity for this one? So for sorting, if whatever the sorting technique that you use, at worst case, if you use bubble sort or insertion sort or selection sort, it will become n power 2. Okay, if you use a better sorting algorithm, it will become n log n. It will become n log n. So these is the sort time complexity for sorting. After that, that's all. We don't need any other time other than sorting. Once we sort this array, we can get the element at index 1, and that is the second smallest. So the time complexity is n square if you use bubble sort, insertion sort, or selection sort, and it will be n log n if you use merge or quick sort. So now the point is there any better way to solve this without sorting? So there is no point of sorting, right? I don't want to arrange the element in sorting. I don't want to lose the order of the elements. I just want to know the second smallest. So what we can do for this? So for this, what we can do is we can simply find out the maximum. We can simply find out the smallest element, the minimum element in the array. So if you go through this array, what is the first element? Let's take a variable small. Let's take smallest element equals to. So when we are finding out the smallest element, we need to make this. Let's take the max possible value, triple lines. Now, initially, this is the smallest value. Now, let's go to my array. So what is the first element I have? It is 8. 8 is the first value. Now, which element is smaller? 8 is smaller or 99,999 is smaller? Obviously, 8 is the smaller value. So we will simply update this triple line with 8. Okay, update this triple line with 8. And we will go to the next element of the array. We'll go to the next element of the array. What is the next element? It is 4. What is the next element? It is 4. Now, which element is smaller? Is 4 smaller or 8 smaller? Which one? 4. Obviously, 4. We'll update this array with 4. So this is removed. This has been removed, and now it is updated with 4. What is the next element now? It is 10. Now, which element is smaller? 10 or 4? Obviously, 4 is smaller. We'll keep it as it is, and we'll go to the next element, which is 17. Now, again, 17 and 4. Which element is smaller one? 4 is the smaller one, and we will store this as is. And next, 19 is the smaller one. Or 4 is the smaller one. Which one? 4 again, and obviously 20. So at the end, we will get 4 is the smallest element. But is this what we need to find? No, right? We need to find out the second smallest. Okay, we need to find out the second smallest element, right? We need to find out the second smallest element. This is the first smallest element. This is the first smallest element. Now we iterate on this array once more. Okay, we will iterate on this array once more and we will find out the second smallest. How we will find out? We will see. So second smallest equal to this will also be the maximum value for initially. Okay, this will also be the maximum value initially. Now again, I'll go to value 8. Now 8, what we need to do? Is this 8? Is this 8? Is this 8 less than 99,999? Obviously, yes. Obviously, yes, right? So we can simply update this value with 8. Okay, now we are at index 1, which is element 4. Now 4, we are with element 4. Now the first thing that we will do is we will check with just smallest. Okay, 8, which one is smallest? Obviously 4. But is this 4 the smallest element? Okay, this is smallest, but we need to check, is this for the second smallest element? How we can know if this element is not equal to the smallest element that we figured out? Then there is a possibility that this can become a second smallest element. Okay, if this particular element is, if this particular element value 4, if this particular element is, okay, not equal to the smallest element that we find out. Okay, if this is not equal to the smallest element that we find out, then there is a potential possibility that it can become a smallest element. Now if you observe 4 is equal to 4, so then this cannot become a second smallest element, we cannot update it. Okay, now next element is 10. Now we will go 10. Now which one is smaller, 10 or 8? Obviously 8, right? We'll not update the second smallest. Okay, and next 17. Which one is smaller? 8 is the smaller one. And next 19. 8 is the smallest one. And 20. 8 is the smallest one. That's all. Pretty simple, right? So this is the approach that we follow, guys. Every time we have an element, every time we take an element, the first thing that we do is this, is this a smallest element? Is this a smallest element? So how we can check? So is this the first smallest element? That is the first thing that we need to check. Is this the first smallest element? So we'll simply compare, is this equal to the smallest element that we find out in the first step? So if they are same, okay, what we need to do? We need to simply skip this element. And okay, we need to simply skip this element. If they are not same, let's say 20 is, okay, let's say 20 we have taken and 20 is not equal to 4. Now what we need to do, we need to check whether this can become a second smallest element, whether this can become a second smallest element. So there is a possibility it is not equal to 4, okay, but there is a possibility that it can become the second smallest element. So in that way, we find out the second smallest element. We'll find out the second smallest element. Now, let's try to write the pseudocode for this particular thing. So what is the first step, guys? Find smallest element from array. From the array, we need to find out the first smallest element. First smallest element from the array. Okay. And after that, what we need to do? Find second smallest. Second smallest. How we will find out the second smallest? Obviously, first smallest is nothing but we will simply take this small variable and we will update with the values. How to find out the second smallest? So first thing we need to do is we need to find out whether the current element is equal to smallest. Current element is equal to first smallest. Okay, first smallest. If the current element is equal to first smallest, then 1 second. Yes. If current element is equal to first smallest, sorry, then we need to simply skip that. If current element is equal to first smallest, what we need to do? Skip that element. Okay. If that is not equals, then what is the potential possibility that we have? Then we need to compare with second smallest value and update it based on value and update it based on the condition. If it is small, then we'll update it. If not, we'll simply skip that. That's all, guys. So first we need to find out the first smallest element from the array. And second step is find second smallest. How we'll find out the second smallest? So for every current element, you need to check whether it is equal to first smallest element. If it is equal, then simply skip that element. If it is not equal, then you compare with the second smallest value and update it based on the values comparison and the condition, basically. Is this clear to everyone, guys? So with the same pseudocode, what we will do now is with this pseudocode, we will try to solve one example. So let me take one example here. So let's say we have elements nums equal to, yeah, let's say we have 4, okay, 6, 2, 7, and 8. Now, if you see, what is the smallest element? So how you will find out the smallest element? Smallest element will be 2. Obviously, we know. While iterating this array, we can find out the smallest array easily. Now, what is the second smallest? Second small equals to, initially it will be the maximum value that is possible. Okay, this value you can figure out from the constraints given for the question. So now for now we are taking it as a maximum possible value. Now what is the thing that we need to do? Every time, okay, every time for this step, for every element we need to do this process. So first I'll go to the first element, which is 4. What is the first element, guys? That is, the first element is 4. Okay. Now, after going to the first element, what is the first thing that I need to do? I'll just check whether the current element is equal to the first smallest element. Okay. Now I'll compare this with the smallest element that I have, 2. Are they equal? Obviously, they are not equal. Then what I will do, I'll take this element to the second smallest. I'll compare. Okay. Which one is smaller, guys? 4 is smaller or this one is smaller? Obviously, 4 is smaller. So then I'll simply remove this and update with this 4. Okay. Update this with the 4. That's all. Now I'll go to the next element, 6. I'll take this 6 with, compare with the smallest element. Are they same? Obviously, they are not same. I'll go and check whether there is a possibility that this 6 can become a second smallest. Obviously, I'll check. So which one? 6 is smaller or 4? Obviously, 4 is smaller. So I'll simply skip this value. Now I'll take 2. I'll compare this 2 with the small. Are they same? Yes. So I'll simply skip this element. Now the next element is 7. So is this 7 equal to 2? No. Now I can take this element to the smallest element. The smallest element is 4. And which one? 7 and 4. Which one is small? Obviously 4 is second small. So I'll keep this value as it is. Now I'll go to 8. Is this same as 2? No. 8 is not same as 2. I'll take this element to compare with the second smallest. What is the second smallest element? It is 4. Now 8 and 4, are they, which one is smaller? Obviously 4. I'll keep it as it is. And after that, the array is completed. Now, after this entire process, what is the second smallest, guys? 4. The second smallest is value 4. And this is the simple approach. And okay, now what is the time complexity for this? To find out the smallest element, we will take n times. And to find out the second smallest element, we will take another n. So it will become 2n. Okay, in which in terms will become, okay, big O of, which will in terms become big O of n. Okay, now the task for the day is, you need to find out a way to reduce this to n. Okay, in total it will become big O of n, but the thing is, internally it is taking 2n times. So now the task for the day to everyone is, guys, just take some time and try to figure out, is there a possibility to reduce any one n? Okay, just, okay, this is what the thing. So for this, I'll give you a lead here. So the lead is, find out first smallest and second smallest n in a single iteration, in a single for loop. Okay, in a single for loop. Okay, that is what the thing is. So that's all. I'm skipping this part because this is task for you people. Now let's try to code for this particular thing, whatever that we have discussed. So let's take this array int nums equals to let's say 2, 4, 1 3 1 0 3. Okay, now int n equal to 5. Now what we need to do, we need to simply iterate on this array. So int small, second small, which is equal to 999. Even the same here. Okay, now find out the find first smallest element. Okay, now okay, how you'll find out the first smallest element, guys? So for int I equals to 0, I less than n, I plus plus. Every time when you're iterating, you need to simply check if nums of I is less than small. If so, simply update this small with nums of I. Okay, internally, this is the logic that is being used by compilers also to find out min and max elements. Okay, after this particular value, well, let's print and see what if we are getting system.out.println line. So smallest equals to, sorry, now we need to find out the second smallest. For again int I equal to 0, I less than, and I plus plus. Okay, now what is the first thing, guys? For every current element, let's take current element also. Current element equal to nums of I. Okay, now for every current element, what you need to do? If this current element is equal to small, what we need to do? Skip the element, right? Okay, that's all. If not, what we need to do? We need to check. We need to check. What we need to check? We need to check whether this current is less than the second small. If so, we'll simply update with second small equals to current. That's all. And after this entire iteration, what we can do is we can simply print the same thing. Second smallest equal to second small. That's all. Very simple thing. So first step is to find out the smallest element, and after that we need to find out the second smallest element. And when you are finding the second smallest element, okay, when you're finding the second smallest element, we need to get the current element, whether we need to check if it is equal. If it is equal to small, skip that element. If not, check if it is less than second small. Check it is less than second small. If so, update it. That's all. Now let's run this and let's see. So from this given array, what is the output, guys? The output will be smallest element is 0, second smallest element is 1. So we'll check whether it is smallest element is 0, second smallest element is 1. So this is all, guys. Now task for you, everyone. As I said previously, you need to combine these two for loops. How you will combine, how you will do, that's the task. That's all, guys. Thank you.